So Kubernetes is just like it is the software where we can deploy the container using the Kubernetes. Okay, so what is pod? What is container? So pod is just like application. You can say it's like a virtual machines and the application running inside the pod, inside the container. So in the earlier stage, suppose this is my virtual machines. Okay, so in this virtual machine I have deployed one application like Flipkart application I have deployed over this VM. Okay, so this VM needs what operating system? This operating system needs some CPU, RAM. So this is the hardware, like on the we are manage the hardware, like in the hardware sense, like we have to manage hard disk, network and the operating system. Then later, like technology move into the VMware. So in the VMware, what we have managed, we have one EXI host. So on the top I have deployed the virtual machines, one VM, two VM, three VM. So on the top I have same, we have deployed the application like Flipkart application, Flipkart app, Amazon app. Amazon app. So later the technology move into the cloud. So this is the cloud, and this is there are multiple provider. One is Azure, second AWS, and the third one is GCP, Google Cloud. So here, like, we haven't managed the hardware, we have just take the virtual machine we have rented from the Microsoft, and we can deploy the application. So this is, suppose this is the application, Flipkart. Flipkart. So, but in all the case, what I observed, like where we have operating system, we have to manage operating system, OS, RAM and CPU. Okay, so if I use Google Cloud or if I use the Azure service, then we have to take the one virtual machine on the top of virtual machine. I have to install the application either in EXI host where we have purchased, we have create the virtual machine. On the top I have to deploy the application. Okay, but in container, in the Kubernetes, what we so in the Kubernetes, what the Kubernetes provide us. So suppose this is the one, I have taken one virtual machines, this is my virtual machines, this is virtual machine. So on the top virtual machine I have created multiple pod. So this is the pod. Pod means container. So inside the pod we have created multiple container inside the pod. So this is the pod. And this virtual machine we are telling the node. This is called as a worker node. Worker node where we have running our application as a pod, as a container. Okay, so in this pod, what, there is no dependency of the operating system inside this pod. So here we have managed image. So inside the image I have defined the, we are used some extension of binaries of the operating system. So you can say like we have created a Docker file, and we can create the image from the Docker file. So the developer create the image, create the Docker file. Suppose the Docker file they can create. So once they can create the Docker file, we have create the image from the Docker file, and with the use of this image we can deploy the pod. And which language we are using here? We are using the YAML file for deploy the application. So this is I will explain in later very deep, like this is just a demonstration. This is just like a brief intro about what are the topic we have to cover in this session. So this is the YAML file. So we have to deploy here. So this is a YAML file. With the use of YAML file, we have to deploy the pod. So pod, you can say is a pod is just like application, like Flipkart application, where you can see in the earlier topics. Like pod, like we have deployed the Flipkart application as a pod. So you can say pod is just like a application. Okay, so inside the pod we have deployed multiple container. We can deploy 2 application inside a one pod. Okay, and where we are using the virtual machine, this is called the worker node. Okay, so there are the two types of Kubernetes cluster. One is for there are two type of Kubernetes cluster types of Kubernetes cluster. One is bare metal cluster, and the second one is managed cluster. So bare metal cluster, in this bare metal cluster we have to manage master node and the worker node. And in the managed cluster we have managed only the worker node. So I will explain what is master node, what is worker node. So for that we have to open one diagram. So inside this master node we have 4 components. So the component is API server, second is etcd, third one is scheduler. So these all are responsible for creating the container and the architecture. This is called, we can say, the architecture of the Kubernetes. Scheduler and the control manager. So this is the architecture of Kubernetes, and there are 3 components of worker node. One is kubelet, second is container runtime, third one is kubeproxy. So that I will explain later. So I just give the demo, like what are all the component, what are the architecture of Kubernetes, how it works, what are the function of API server, what are the function of etcd, what is the function of scheduler, what is the control manager, what is the function, and what is kubelet, what is container runtime, what is kubeproxy, and how it works. Like if API server down, then what are the impact over the cluster? Because when you like attend any interview, the interview asks you, so tell me about, if API server is down, then what are the impact over the cluster? If etcd down, what are the impact over the cluster? If scheduler down, if kubelet down. So this is type of, like they can just asking this type of question, like if API down, container runtime down, what are the architecture of Kubernetes, what are all the component of master node, what are all the component of worker node. So those things we'll discuss in like in tomorrow's session. We can start from the scratch. So I just give you the basic info about the Kubernetes and the architecture, what the topics I will cover. Okay, so here I have created one Kubernetes cluster. So I will, so here, so I will show you, like I will explain what is kubectl, what are the use of kubectl, how to connect our cluster, how to authenticate ourselves so that the API server will allow you to perform any activity over the cluster. So I will discuss about how to integrate our Kubernetes cluster with RBAC and Azure Ready. So here I have created one cluster and kubectl get node. Okay, so here we have only one worker node is running. So inside this worker node I have deployed multiple application. Kubectl get pod. So you can see it here. One pod is running, web app pod is running, Apache server is running, kubectl get ns. So I will explain what is what is namespace, and right, what are all the service we are using in Kubernetes, how many types of deployment. So those things we'll discuss in details. So here I have set up one Jenkins server also, like if you heard about Jenkins, so I have set up Jenkins pod, kubectl get all -n Jenkins. So here you can see it here, one pod is running, like one application, one Jenkins application is running, and I have access to the URL. So this is the dashboard of the Jenkins. Like how do we access? Like I have set up the pod. So how do we access those pod? Like which service we have to use? How the traffic flow from outside cluster to inside cluster? So those architecture will discuss, like how traffic flow from inside to outside, what are the architecture of Kubernetes, how do we access the application. Suppose I have deployed the application, so how do we access those applications from outside, like a user are sitting in the US and they want to access the server from India. So how do we access, which service we have to use. So I have set up the Jenkins also, I have set up the Apache server, I have set up the Rancher. So here you can see it here, one web app, Tomcat, Velo. So I have set up the backup also, like if I delete any namespace or if I delete any pod, so how do we restore it? How do we restore it from the backup? So those things we'll discuss, like how do we set up the backup and restoration over the Kubernetes cluster, and how do we migrate the cluster. Like I did my in my project, like bare metal Kubernetes cluster migrated to AKS. So what are all the tasks involved during the migration, what we have to check, what are the pre-tasks, what are the post-tasks during the migration, like how do we migrate the resource from one cluster to another cluster. Suppose you have one dev environment and you want to migrate the dev environment pod, like some resource are running in dev cluster, you want to migrate this resource from dev to prod cluster. So how do we achieve this, how do we migrate this. So here I have set up backup pod, kubectl get all -n Veloro. So I am using the Veloro as a backup tool. So you can see it here, I have set up the backup server as a pod, and this is the command, like if you want to see the backup status of the pod, so this is the command. So don't worry, I will show you, like I will start from the scratch, like what is kubectl, what are the command, what are the basic command. So in the next session we will start from the scratch. So I just give the brief introduction what topics I have to cover. Okay, so here you can see it here, one backup pod is running. So I have taken the full backup of this namespace web app 2. So this is the namespace. So namespace is just like a logical container, like a resource group. Like if you heard about the resource group in Azure, So similar way in the Kubernetes namespace, just like a resource group. So inside the namespace you have to create multiple resource. Suppose this is the namespace. This is the namespace. So namespace is a component of Kubernetes. So I have created one namespace. So inside the namespace I have deployed the resource, Kubernetes resource, like I have deployed the application. So for the application, what all the object we have to create, like we have to create one service, we have to create the persistent volume. So persistent volume is just like data, like if you are using Azure or AWS, so there you are using the disk for storing your application data. So in Azure you are using the Azure disk, in AWS you are using the EKS. So similar way in the Kubernetes we are using the persistent volumes. Persistent volumes. So persistent volume is the disk type, like where you can store your pod data inside the persistent volume. So I will explain like how do we create the persistent volume, what is persistent volume, what is storage class, how do we use the persistent volume to the pod, how do we use the existing persistent volume in different pod. Okay, so understand what is pod and all the things. Hello. Hello.
Yes,
Yes.
sir.
Okay. So I will, don't worry, it's just like demo session. I will explain from the scratch like what all might be, it will be bounced from most of them. So persistent volume just like a disk where we can store our pod data. So I will show you how do we create the persistent volume. So I already showed, I have already created volume. If you go in the volume tab, you can see it here, the web app to web app PVC. These are the volumes. Our bound state means healthy state. So sometimes you are facing some issue like some PVC and pending state. So this is the production type issue. Like I face this type of issue like some PVC are stuck in pending state. So how do we fix the issue? What we need to check? Why this PVC? Why this kind pending state? Okay. Similar way in the workload, if you go inside the workload, you will see some pods are unknown state. Like this pod, this application is down. So how do we fix the issue? Okay. So similar way, if you go down, so I will if you go, this is the Rancher is the open source tool. So where in the Rancher we can manage the Kubernetes cluster. Like if you in the environment you have 50 or 100 plus cluster, so it's very hard to manage, like you have to connect the cluster each and every time from the PuTTY. So it's very hard to manage. So for that we are using the Rancher. So Rancher is the open source tool. It gives the GUI interface, like it is give the a GUI dashboard where you can see it here like how many cluster you have. So for demo lab I have set up one cluster, and you can see it here in the Rancher there is one cluster is showing, but in the production environment you will see like a 15 plus 20 plus cluster inside the Rancher. Okay, so I will take the one session, one full day session on the Rancher, like how do we set up Rancher, how do we add a cluster into the Rancher, what are all the features in the Rancher. I will give the full details about it, like how do we manage this Rancher, what are all the features. So don't worry, just I'm giving the brief intro about this Rancher. Okay, so let's come to the point. So here I have created one project with the prod name. So if you go there, this is the pod. Pod, what I said, pod is just like application, like Nginx application running is like as a pod. Tomcat application it is like a pod. So Tomcat running inside Tomcat running as a pod. Okay, if you go there, Tomcat, so you can see it here, image pullback of error. So this is the very common issue when you get a chance to work in Kubernetes. So you will get like you will encounter this type of issue, like some pod getting image pullback of error. Okay, so how do you fix the issue? Sometimes the interview asks you like one of the pod getting image pullback of error. How do you fix the issue? Image are already in the container registry. Okay, so but still I'm getting the image pullback of error. So those scenario type question the interview asks you, they like just they like looking like you are genuine person, you have work in Kubernetes or not. So that's why my session is like the main motive of to create this session is only to provide the real time training, real time session, so that like you can tell them you have worked from past 2 years in Kubernetes and you have encountered this type of issue, you have facing this type of issue. Okay, so I will cover 20 plus live troubleshooting, like some pod getting image pullback, some pods are getting crash loopback, some pods are in pending state, some PVC are in pending state, application URL down, sometimes this Jenkins application URL down. So how do we fix the issue? How do we like find the root cause why this application down, we are not able to access this application, what is the root cause and how do we fix the issue? Suppose you are running with Apache application running as a pod, this Apache URL is down, so how do we fix the issue? So this type of question the interview generally asks, like if the URL down, if the application down, so how do we fix the issue? Okay. So similar you can see it here in my lab also, you can get a lot of issue here. Some pods are in scheduling state, some pods are in error state, some pods are in crash loopback of state. So don't worry, I will fix all the issue in front of you. Like you can see what are the way of troubleshooting, what we have to check, like what are the first step to fix the issue, how to read the logs, what how to filter the logs, because when you run the command to check the application log, there are thousands of lines. So how do you filter those logs? What are the keyword? Okay. So these are the like I will start the topic from the scratch with the syllabus. So we'll start from what is Kubernetes, how many types of Kubernetes, and what is the master node, what is worker node, what are all the component of master node, worker node, how do we create the cluster, how do we upgrade the cluster, because every 4 and 5 months you have to upgrade the cluster. And the interview asks you the definitely they can ask you about the question related to upgradation, because if you really work or like you have a chance to work in Kubernetes, definitely you have to upgrade the cluster every 4 and 5 months. So I will show you like how to upgrade the cluster, what are the pre-tasks, what are the post-tasks, like what all the challenges, what type of issue generally we face during the upgradation. So that if the interview asks you tell me about like what are the challenges you face during the upgradation, so that you can explain very well, yes I did the upgradation of this version to this version. Because if you mention the version detail, then they can like understand you definitely work in Kubernetes. That's why you are telling very confidently like you have worked on this version, cluster version 2, and you have to upgrade to the latest version. So currently we are using 1.25 cluster version, and you can tell them you have worked on the 1.22, 1.23. This is the cluster version. And what are like how do we upgrade the cluster? Okay, and I will show you like how many types of issue during the upgradation. Sometimes upgradation failed. So how do we like fix the issue? Okay, and sometimes like how do we upgrade the cluster with zero downtime? So sometimes the interview asks you, I want to upgrade the cluster but I don't want to impact in any of the application, so how do we achieve this one? Generally the during the upgradation the node will be restarted, but in Kubernetes like how do we achieve this one, like with zero downtime, how do we upgrade the cluster? Okay, and how do we expose the service, like if you had a NGNS ingress controller, and HPA like horizontal pod scaling. So how do we configure the HPA? So I have already configured the HPA in our environment. So So SPA is just like it is the service horizontal pod scaler. So in SPA, what suppose this is the application. Suppose this is the pod. This is the pod, and heavy traffic like this is a traffic, and this pod having CPU is 2 core, memory is 2 GB. This is pod. Suppose the very high traffic or heavy load over this pod, then the utilization reach up to 90%. CPU utilization is 90%. So in this case, if you haven't enabled the HPA, HPA is a horizontal pod scaler. So what they did, HPA, horizontal pod autoscaler. So if this CPU is 90%, in this case generally what this pod will be down. This pod will be down. If we get the 90% utilization, this pod will be down and getting the OM killed. Like if you heard about OM killed error. OM killed error. So when you encounter OM killed error, then you have to check the utilization of the pod, because OM kill generally occurs due to the heavy load or heavy CPU and memory over this pod. So you have to increase the CPU like from 2 core to 4 core or 4 to 8 core as per the requirement. But what horizontal pod autoscaler did, so they will create the another pod. They will create the another pod with the same replica, like this pod, like this is a Flipkart application pod, then the new pod will be come up and the traffic will be distributed, like some traffic goes here, some traffic goes there. So traffic will be distributed so that the CPU will be down. Because on the one pod we are getting 90%, then the SPA create the one another pod and the traffic goes into the two-way, like a 45% utilization there and there is 45% utilization. So if still the load will be heavy, like this pod also create like getting the 90% utilization, and this pod also getting the 90% utilization. So this pod also getting 90% utilization. Then in this case, what HPA did, they can create another pod, pod 1, pod 2, pod 3. So we have to define the limit, like how they can go up to, what are the limit, like pod 3, pod 4. So once the load will be decreases, so when the load was the heavy, so at that time they have created 3 pod. Once the load will be decreases, like CPU count 90 to 40%. 90 to 40%. So in this case, the new pod will be deleted automatic. All the new pod will be deleted and they can reach up to the initial state at the time of pod 1. So let's show you in the lab also. So kubectl get all -n get all get ns kubectl get all. So I have configured the HPA here, you can see it here. This is the HPA, horizontal pod autoscaler, and right now we have set the target is 50%. Like if the CPU getting the 50%, then the new pod will be come up. So in this case you can see it here, this is the Apache pod. This is my Apache pod where I have configured the horizontal pod autoscaler. If this pod is beyond the 50%, then the new pod will be come up. If the load will be decreased, then the pod will be deleted. So we have to increase the load. Right now we have zero load, like 0%. You can see it here. This Apache pod having only 0% utilization. So we have to increase the load. So for that we have to run this command. So this is the command to increase the load. Let's run this command. So right now still we have 0% utilization and one pod is running. So you can see it here. One pod is running, only one pod, and the utilization is only 0%. So don't worry, I will show you from the scratch, like how do we set up the SPA, how do we create the pod, how do we run the load generator so that the pod getting the heavy load. So those things will start. So now you can see it here, we have 250% utilization. So let's stop this load generator. Now you have to check the more of the pod will be created. So initial time only one Apache pod is there. So right now you can see it here, with the 30-second ago the 3 pod will be come up. Okay, so in this way, like SPA work, once this load will be decreases, automatic this pod will be deleted and it will reach in the initial stage. But initial stage the only one pod will be running there. So still 250 50%, so we have to wait for 5 minutes. After that you can see the rest pod will be deleted, and you can see it here, most of the pods are in pending state. So this is the troubleshooting, like how do you fix the issue, why this pod is pending state. And this is the production based issue, like I have encountered this type of issue, one of the pod getting in pending state. So how do you fix the issue? Even interview ask you like one of the pod getting pending state, and how do you fix the issue, what is the root cause, and what are the solution. So once I will fix the issue, so you can tell the same, like what are the command you have to use to fix the issue, what are the steps, what are the way of troubleshooting. So you have to explain all the things. So right now you can see it here, earlier it was 250%, now it is this up to 0%, and after a few minutes then the rest of the pod will be deleted automatic. So this is the advanced features of Kubernetes, like if load happens over the pod, then the pod will be scale up. If load happen over the node, then node will be auto scaling, the new node will be come up. So this is the one way of cost optimization, like if the interview asks you like how do we achieve the cost optimization. So you can say it here, we have to set SPA.
Hello?
Okay. Yes. Hello.
Uh, what is saying? We are not understanding because we need a basic comments now. Without basic comments, directly you're telling me how we can understand all the things.
Then I just show you the lab, like what the topics I have to cover.
No, before you understand the lab, first theoretically you have to explain. No, means how to we have to create the pod, how to we have to create the cluster.
Yeah,
That is the
that I will start from the tomorrow. Today I'm just giving the demo, like what are the topic
demo.
I have to cover.
How much time it will take for demo? It is 1 hour or 2 hours?
No, 1 hours, 1 hour.
Only up to 9 is the last, huh?
Yes, yes, yes. Only
Because
one.
nobody not asking questions, because nobody not understand. Directly you are involving in theory part, practical part, mainly as
Mm-hmm.
per jobs. That's the one problem.
Mm. Okay, no worry. Once the student will be confirmed, then we can start from the scratch. I have already shared the course content. So based on that, we'll start from the course.
Javed sir, I wanted to know what all more
Mm-hmm.
things you are going to cover up in this thing. Like,
Mm.
is it only this much or something more are going to be added into it?
Yeah, more like first we have to start from the scratch, like what is Kubernetes, how many types of Kubernetes, what are the master node, what is worker node, what are the component of master node, what are the component of worker node, and what is Azure AKS cluster, what is bare metal cluster, what is managed cluster. Okay, so what we have to manage in bare metal, what we have to manage in managed cluster, how do we create the cluster from scratch, what is rancher, how do we set up the rancher, how do we add a cluster into the rancher, so how do we set up the alert for cluster, like if pod went down, then how do we get the alert over the email ID. So how many, what is service, how many types of service, how many types of secret, what is secrets, how many types of secret, how do we create the SSL certificate, so how do we upgrade the cluster, and what is a repository, how do we push and pull the image from local machine to private repository, what is persistent volume. So those things will start from the scratch level, what I have mentioned in the topics.
Look, sir, in the
Hmm.
master code, we have explained that the API server, etcd,
Hmm.
scheduler, control manager, basic things.
Yes,
First,
yes.
we want to know about that. What is the API server? What is
Yeah,
etcd,
that will start from
scheduler?
the tomorrow. What is from the,
Tomorrow.
yeah.
That you cover from scratch itself
Yes,
only, right?
from scale. What is etcd, what is API, what is
You
scheduler,
explaining,
how it works.
yeah, you explaining something like pod, node. So
Yes,
that
yes.
things
We'll
also
explain what is
we need
pod,
to
what is
know.
node. Yeah.
Oh, that thing also you can explain, right?
Yes, yes.
Okay, thank you.
So, Tariq, so are you going to show us with the bare metal cluster creation as well, right?
Yes,
So,
sir. Cluster creation, I will show how do we create the cluster so that you can also set up a lab in your environment, and you can practice what I have to mention is daily you have to
yes,
practice. Yeah.
that's a bare metal cluster, right? So
Yes,
bare
no,
metal
no, not bare
will be
metal. We have go through the managed cluster AKS.
okay. No bare metal,
No,
correct?
no bare metal. We have to manage AKS because Azure Microsoft providing 1 month free subscription. You have to create the account that are free for 1 month, and you have to set up the cluster there, and you have to do practice like how do we create the pod, how do we create the service, how do we access the pod, those things.
And you're telling the Kubernetes means that belongs to Azure or AWS DevOps?
Here we are using only the platform like either Azure, AWS, Google Cloud. They are providing the platform. Like we have to set up the Kubernetes cluster, but the Kubernetes concept are same in all the environment, either in the Azure or in AWS or in GCP. Like Kubernetes concept, like how do we create the pod, what is kubectl, how to run the kubectl command. So kubectl command are the same in all the environment.
Means which is the best one, AWS or Azure?
Based all the one Azure, AWS, Google Cloud.
Mm.
So for my side, like Azure is the best.
Mhm.
Yeah,
So I
because
have tried
Microsoft.
that.
Hmm.
Uh, I have tried on the AWS, but it is different from the Azure
Yeah,
while updating the.
yeah, not different. You have to set up the EKS cluster in AWS, and you have to do practice like what all the create. The YAML file will be deployed in all the environment, either AWS or Azure. When I have shared the YAML file, so you have to deploy the application in AWS also or the Azure also.
So actually, we are not aware about the Azure.
So
So
I
how
will
will
start from the scratch like how do we create the cluster, how do we if we are using any resource in the Azure. So that I will explain, like if I am using the storage account in Azure, so I will explain what is storage account. Okay, so how do we use the storage account in the AKS. So you can compare, like here we are using AKS, so you can like compare in the AWS, like you're creating the EKS.
Right.
Yeah, EKS there, and the repository are here we are using the ACR repository. So in AWS you are telling you are using the ECR repository, right? So
Stick container.
yeah. But yeah, once the platform will created, either Azure, AWS, then rest all the other are the same. Like how do we create the persistent volume? How do we extend the persistent volumes? Right? How do we create the storage class when we are creating the YAML file? So based on that, how do we create the storage class, persistent volumes, and the
What about
pod
placement? Placement
placement? What?
means present the Kubernetes means there is a lot of job openings regarding to the
Yes,
this one.
there are a lot of job winning only for Kubernetes profile also, because
Mhm.
in DevOps also Kubernetes using, because in the DevOps when you have set up the CI/CD pipeline, so CD is the deployment type, like where you can deploy your application to the Kubernetes platform. So if you learn the Kubernetes, then you have to also enter into the DevOps side. But for Kubernetes profile, there is separate profile, like company hiring only for the Kubernetes project, because the DevOps guys what they have deploy the application, but the company needs the team to manage the Kubernetes cluster, because in the company we have 200 plus Kubernetes cluster, so they require a team to manage the Kubernetes cluster, because in Kubernetes cluster there is like you have to day-to-day tasks, like how to upgrade the cluster, sometimes pod down, sometimes cluster down, sometimes issue with the persistent volume, sometimes issue with the service, sometimes pod down, sometimes application down, so they require a team. So that's why the separate opening only for Kubernetes are also available.
Mhm.
And if you want to move in the DevOps side, then this is additional. Like you already learned, you already know the Kubernetes. Then only thing you have to learn the CI/CD pipeline, either
Mhm.
in Azure DevOps, Jenkins, and Terraform. You have to learn.
Yeah. Actually, you show me, right? You teach me for integration with Jenkins or Kubernetes. Huh?
Yeah, Jenkins I will set up, because this Jenkins setup is responsibility for the Kubernetes guys. So the developer have requested like I need Jenkins server, so that we have to create the pipeline. So that's why I'm adding this Jenkins part in our lab. Like how do we create the Jenkins?
Tarik, real time, right? So, are you creating the parts and to the YAML file? You create a YAML file, or the developer give you the YAML file and you deploy it? Or
Yeah,
how?
developer created YAML file, and but you have to know about the service PVC. They have created the YAML file, but you have to create another thing like ingress object, persistent volumes, or the service you have to create.
Okay. So in real time, so if the developer what they will give and what you will create in the Kubernetes side.
Yeah, in real time you have to responsible to create the cluster, and then you have to manage the cluster. The YAML file, all the things are created by developer, and they can share, they can push the image, they can also developer create the image, they can push image to the container registry. So container registry is the registry where we can manage all the images. So
Okay, I think the cluster creation and these are the one
yeah,
time job,
manage,
right?
yeah,
Oh,
one time
yeah,
job. Hmm.
yeah. what is it that in our day-to-day activities in that?
So day-to-day activity, you have to manage the cluster. If any new requirement come, like client I want to deploy this application. So you have to take the code and you have to deploy the application. And then you have
So
to access the application. You have to create the service to expose the application. You have to renew the certificate, like certificate you have to create SSL certificate, and you have to import the SSL certificate into the application. Like
so
you.
you okay.
Mhm.
So you get the code, the YAML file from the developer, and
Yes.
the responsibility to deploy that in the pods are
Hmm.
responsible for us is the Kubernetes, right?
Yes, yes, right.
It's not a developer they will deploy it. Right?
Hmm. Right.
So, for all these, as you mentioned, all the problems. So, for in the organization, which type of tools
So your voice is very low. Hello. Hello. Hello.
hello.
Yeah. Yes.
So I'm asking, what type of ticketing tool you are using, or
Ticketing tool we are using SM9 service now.
so we have to create that ticket, right?
No, sometimes ticket created by the customer. Like if they want to deploy anything in the Kubernetes cluster, they have to create. They have to raise a ticket like I want to deploy this application. I want to export the. I want to access this application, right? So they have to raise a ticket. Very less ticket like they have created. Only if any new requirement or if any issue happened, then yes, Raj. So we are just stopping for now. Like from tomorrow, we can start from the topic wise. What we have mentioned, we have started from the scratch. Okay.
Sir,
Tariq,
tomorrow
Mm-hmm.
you told me to install the cluster first. Before that, we need to know that orchestration,
Yeah,
right?
we before to
Single,
create the cluster, we have to discuss about the
single.
architecture
Uh,
and of the Kubernetes, like how it works and what are all the component, what are the function of those component. So that we start from the scratch. Like
that
what is called,
installing of that
yeah,
logging and
installing.
monitoring of dashboard also.
Yes, yes.
Okay, okay.
Mhm.
Thank you.
Okay, yes, you can ping me. You can confirm your like availability so that we can schedule for the next for tomorrow. Okay.
So
So yeah,
tomorrow same time, right?
yeah, same time,
Uh,
8 p.m. Yeah, 8 to 10 p.m. Tomorrow we can start for 2 hours. Tomorrow we can start from the scratch level from the topic wise.
okay, the same link, right? The same
No,
link
no,
will be.
link will be sent once you have the confirm your ability. So I will share the link individually once you have.
Okay.
Mm.
Tariq sir, I just wanted to ask you that the classes will be every day or it is going to be only on Saturdays and
Saturday,
Sundays?
Sunday.
Acha,
Saturday,
okay,
Sunday.
okay. So will there be a timing like will be the class will be for 1 hour or 2 hours or
2 hours.
3 hours?
No,
Acha,
it's not
maximum.
like yeah, no, it's not time bound. Like it's depend upon the topic. I have covered all the topic. There is no time bound. If need,
Acha,
then we can extend also, and we can
okay,
extend also the week.
fine, fine, sir. Yeah, thank you.
Mm-hmm. Okay, then you can ping me for your confirmation so that we can send the invite separately. Okay.
Yes, sir. Thank you.
Okay. Yeah. Thank you. So.